Welcome to a video that will show you how to graph lines on the TI83 or TI84 graphing calculator using the graphing feature as well as the table feature. So let's say we want to graph the line y equals negative 2x plus 3. Slope-intercept form is the perfect form to enter into the graphing calculator because the graphing calculator does require the equation to be solved for y. So if we have our calculator, the first thing we'll do is press y equals, as we see here on the top left. If you have any other equations in y1, y2, and so on, we do want to clear those, and we can do that by just pressing clear, and then arrow down, clear, arrow down, and clear. Now we'll go back up to y1 and enter the equation. Notice that the y equals is already there, so we just need to type in negative 2x plus 3. Be careful, we can't type in minus 2x, it has to be negative 2x. So we'll use the negative sign below the 3. 2. This key here is for the variable x, and then plus 3. Now before we press graph, let's make sure we have the standard window, which means both axes will go from negative 10 to positive 10. A quick easy way to make sure we have the standard viewing window is to press zoom and then option 6 for Z standard. And now you should see the line graphed on the screen. If we do press the window key, you'll notice both the x minimum and y minimum are negative 10, and the x max and the y max are also positive 10. Now let's go ahead and press graph again. And this gives us a nice visual of what the line should look like, but it doesn't give us exact points to plot on our coordinate plane to make a nice graph of the line. If we press trace, this does give us the point 0,3, but if we press the right or left arrow, notice these other points on the line don't come out to nice x and y values. And this is where the table feature comes in very handy. The table feature would show what you would have if you made a t-table for this line. So let's press second window to set up the table feature. We're going to start the table at 0. The change in the table will be by 1s. That's good. We want to make sure that the independent variable here is on automatic. So we're going to highlight automatic and then press enter. Now we're ready to go to the table. Notice that right above the graph button, there's table written in blue. So to access the table, we have to press second graph. And now we can scroll up and down this t-table to find the coordinates of an infinite number of points that would be on this line. So here's the point 0,3, then there's the point 1, 1, 2, negative 1, and so on. We only need 2 of these points to make a nice accurate graph of this line. So let's go ahead and plot 0,3 and 3, negative 3. So here's the point 0,3, and here's the point 3, negative 3. So our line passes through those 2 points. Now this probably was a lot of work to graph this line because it is in slope-intercept form, meaning the y-intercept is positive 3 as we see here. The slope is negative 2 or negative 2 over 1. So from here we'd go down 2 and right 1. And of course we'd have the same line. Let's go ahead and try another one. Here we have y equals 2/3 x minus 5. We do have to be a little careful when we have a fractional slope in slope-intercept form. So let's go back to the graphing calculator. Press y equals, clear out this line. We're going to enter in 2/3 in a set of parentheses. So we'll have an open parenthesis, 2 divided by 3, close parenthesis, press x minus 5. Now we can graph the line. Press graph. There's the line. If we want to find specific points on this line, we can now just press second graph to access the table. Notice several of the y coordinates are repeating decimals. Remember when we graphed these by making t-tables and we had a fractional slope, we always chose x values that were multiples of the denominator. So if we look at multiples of 3 in the table, These will be the values where y is an integer rather than a repeating decimal. So let's use the points 0, -5, and 3, -3. Here's 0, -5, and 3, -3 would be here. Our line passes through these 2 points. And again, just to verify, we have a y-intercept of -5. Our slope is 2/3, so if we go up 2, right 3, there's our second point. And then just to verify, if we press graph again, our line matches a line on the screen. Let's take a look at a couple where they're not solved for y. If we want to graph this using the graphing calculator, we do have to solve this equation for y. So we want to have this line in the form of y equals, and then everything else on the right. So we'll start by subtracting x on both sides. So we have -2y equals -x plus 4. Now we'll divide everything by -2 to solve this for y. Now we need to be careful here. This would give us y on the left. Now for the -x, we could write -1x, and that'll probably make it easier for us to determine that the slope would be -1 over -2. But a negative divided by a negative is positive, so we'll have positive 1/2 x, and then 4 divided by -2 is -2, so we'll have 1/2 x minus 2. This is the form we have to have the line in to enter it into the calculator. Let's go ahead and try it. To clear this line, we had y equals 1/2 x minus 2. So in parentheses, we'll have 1 divided by 2 times x minus 2. Press graph. Again, there's our line, which is nice, but it doesn't give us exact points to plot on the coordinate plane. So now we'll press second graph. And again, to avoid decimal values of y, we'll use the x-coordinates that are multiples of 2. So let's use the point -2, -3, and 0, -2. So -2, -3 would be here. Let's also use the point 0, -2, which is here. And let's go ahead and just use one more. Let's plot the point 2, -1. And that would be here. So there's our line. And since we took the time to solve it for y and put it in slope-intercept form, notice our y-intercept is -2. Our slope is 1/2. So go up 1, right 2. So it looks good. So it may or may not be easier to graph a line on the graphing calculator, but it is a nice way to always double check your work. I hope you found this video helpful.